We are ready to proceed with the next session, Future Demands and Opportunities, Part 2. Dr. Marios Douvaras from Eratosthenis Center of Excellence and Cyprus University of Technology will be the chair for this session.
Everybody, let's start with the first speaker. We have Dr. Sotiris Alexandrou from the Cyprus Telecommunication Authority that will talk about the satellite station hosting facility. The floor is yours. Please unmute your microphone.
Thank you. Can you hear me?
Yeah, perfectly. Please share your screen.
Okay, I'll do that right now. Oh, I have the last page. Just a second. It's frozen. Just a second.
Given this opportunity, please, to all the attendees.
Okay. Sorry for the glitch. Okay, I'm Sotiris Alexandrou, and I will be talking about Cyta's role in Excelsior and the things we are doing to help this project take off and progress. First, let me say a few words about Cyta. We are a government corporate body. We are the Cyprus telco, essentially. Everybody in Cyprus knows about us. And many people are actually our customers. You see our logos on the bottom, which can be seen everywhere in Cyprus. We offer all types of telecommunication services, from mobile telephony, IPTV, internet, etc. A few people also are aware about our activities in the international market, where we promote business services internationally. We are actually quite active in satellite services and international connectivity. Many of the speakers today mentioned about the benefits of the region and the advantages it offers with respect to the access in certain areas of the globe that are adjacent to Cyprus. We see a role in this project as the entity that will facilitate the introduction of the antenna and make it operational and allow everybody to actually have a fully functioning system and be able to use the data from the satellites dependably and reliably. So Cyta is proposing to host the Excelsior antenna Dermis teleport in Cyprus, where it would be integrated to our own capabilities and offer dependable service for the project. Specifically, what Cyta would do is, first of all, undertake the process for the procurement, installation, and support of the Excelsior's received air station antenna. We will provide the land at the Dermis teleport to host the antenna and the associated systems. We will make available the necessary support, the facilities, the infrastructure, the telecommunication services in order to have the antenna integrated with our facilities and capabilities. And we'll offer our expertise for the operation of the antenna in accordance with the needs and requirements of the project. So we go from a piece of hardware to a fully functioning system, etc. Some words about Cyta's international network. Cyprus is relatively small, but it has quite developed telecommunications infrastructure and the capability to offer all sorts of services in the international market. We operate 3 teleport sites. We have 3 cable landing stations for submarine systems that go from Cyprus to the neighboring countries and mostly to Europe and Asia. We have our own internet node in Cyprus, the network management to oversee the operations, and major international customers and partners. Now, some words about the Cyta's teleport sites. We have 3 sites in Cyprus, Makarios, which is shown in the picture below, Pera, and Hermes, the site that will be hosting Excelsior. We have more than 40 major satellite earth stations and more than 100 receive antennas installed. That's quite an infrastructure, quite a big infrastructure for an island like Cyprus. We have no frequency restrictions or interference of any type. We offer good climatic conditions that are ideal for some services. We have full visibility of the geostationary arc from 35 west to 100 degrees east. This is relevant to geostationary operations. And we have the capability to offer services with enhanced availability by using 2 teleport sites at once. So if there is a problem at one site, you can switch to the next site and continue and provide the service for whatever reason. Now let's talk about teleport infrastructure. In order to be in this business, you need to invest on hardware. And to do that, first of all, you need to have dependable power, starting with power generators and UPS systems of the site. Then you need the associated air conditioning systems to control the temperature. You need dual and diverse optical connections to go to the teleport sites to ensure availability of services. You need a building management system to check your infrastructure and see what it's doing. And then you need a specialized system to support your operations. First of all, you need a carrier monitoring system to see what's going on with the carriers you uplink and you receive. You see the satellite management system for your own equipment to make sure you can control it. You also need security provisions, starting with physical security, network security, information security, supporting systems like fire protection and suppression. And you also need to have additional help if things go bad, like a hotline with the police and fire brigades. So this is all the hardware you need to do the operations. Hardware alone doesn't do much. In order to provide operations, you need people. And for that, you need experience, qualifications, and processes. Cyta has 40 years experience in satellite communications, teleport operations, and related services. We've been active since 1980. The first people who worked at the teleport are now pensioners, but the tradition goes on. We have new people coming in, trained every day, learning the fundamentals, implementing the processes, and improving day by day. The operations are supported continuously on a 24/7 basis, every day of the year. We have qualified shift with experienced technicians that support the services on after hours. We have on-site all the time specialists in RF systems, in baseband systems, and also in fiber network. Our people there monitor the infrastructure and the services, introduce some services, do rearrangements and restoration of whatever is needed. They also do preventive and corrective maintenance according to the relevant standards and whatever happens to be in trouble on the particular day. We also have to do some installations and upgrades for new services that continuously come to the teleport. So the pictures you see are all people's pictures, because it's the people who actually bring everything together and offer the reliability and the dependability that the customers ask. I will continue about this aspect in the next slide. So we have broad experience in a wide range of satellite applications that we acquired through the years. We offer all sorts of telecommunication services, from satellite TV broadcasting to VSAT services, to also new services like gateways for the so-called high throughput satellites that multiply the spectrum and offer broadband services to consumers worldwide, and also for the upcoming constellations. Lately, I'm sure some of you have heard the news that some of these systems are facing financial difficulties, and some of them actually went bankrupt, but the tendency is there. The applications will evolve along those systems, and some of them will be up in the air. Yeah. So we need to be a part of this game and do our contribution. We are also active in non-geostationary operations who are more closely related to Earth observation. I will mention here 2 examples. One is the mail service that was mentioned in the morning, which is a critical service for life support at risk. And the ECNOS receive monitoring service that provides a correction signal for satellite navigation. I will be talking about this in a little bit more. In order to do your operations, you have to build processes, and these processes have to be checked and be certified by others. For this reason, Cyta has applied to the World Teleport Association and has been fully certified at tier level 4. This is the highest level you can achieve certification from the World Teleport Association. It's only 15 teleports in the globe that have managed to do that, and we're proud to be one of those. We are also a member of the Eutelsat Teleport Partner Network, which is also another entity that goes and do certifications, checks on your processes and procedures. We also have ISO certifications, and essentially we engage all the tools that are necessary to ensure that we provide dependable and reliable services. Now, a few more words about MEOLUT. What MEOLUT does is essentially help people in distress. If somebody is at sea and fall in the water and we need to do something about it, this person, if it has a specialized device, we send a distress signal. The signal will go to the satellite. The satellite will bring the signal down to Earth and it will be received in one of our antennas at the teleport. We see the picture below. After we get the signals, these will be processed and will go to a mission control center that would actually dispatch somebody or a team to help these people in need. This is important because it's an geostationary service, but also more important because it's a service that is critical for life support. So you have to make sure that you are dependable, you have to make sure that you are reliable because lives depend on it. Similarly, for ECNOS V3, we are trying to finish our negotiations with the European Global Navigation Satellite Systems Agency, which is responsible for ECNOS in Europe, to install a Hermes receiving station for ECNOS. What the system would do is essentially provide a correction signal for the geolocation systems. So with this correction signal, you increase the accuracy and the integrity of the signal, and you make sure that certain services can benefit from it and be as reliable they have to be. You can have aircraft approaching, you can have search and rescue helicopters going on cliffs, etc. There is a wide range of applications related to positioning and ECNOS, and we hope to be able to contribute to this project very, very soon. The installation is starting sometime this year. So, Hermes Teleport will also be hosting the receiver station for the Excelsior. The teleport is a suitable site for the observation because it has a lot of land and can offer unobstructed satellite access. We can see the horizon from every direction down to 10 degrees elevation, and some directions even lower than that. You see the picture with the panoramic view on the bottom. It's an environment that is interference-free, with checks from the Electronic Communications Department and also the European the GSA, the European Global Navigation Satellite System Agency. It has no restrictions on the use of satellite frequencies and can cover any band we want. So by installing the Excelsior antenna at Hermes, we can have all the fundamentals in order to make this a fully functioning system without any bottlenecks. Some other features of Hermes Teleport and mentioned here. It's an unmanned site, but is well integrated with Cyta's national and international network. It's a protected location and it has integrated security provisions. It has all the infrastructure is needed to support reliable services of all types. It has protected and diverse fiber connections and the desired connectivity to go to Cyprus or abroad. And at the site, there are fully available all types of telecommunication services. So by installing the antenna at Hermes, we will be able from day one to have it fully integrated with Cyta capabilities and be able to produce results for Excelsior. So Cyta is ready to support Excelsior. We are keen to facilitate the procurement, installation, and hosting of the antenna at the Hermes teleport. We're keen to engage with the partners and contribute towards the success and long-term sustainability of the program. And we are also ready to explore opportunities in Earth observation, remote sensing, and associated activities. In a nutshell, this is what I had to say about Cyta's role in Excelsior for the moment, and I hope I give you a better idea of what we plan to do and how we plan to do it. Thank you for your attention.
Thank you, Sotiris, for your nice presentation. We will proceed with the next speaker. We have Mr. George Ellis. He's the Director of Operations of the European Space Imaging. George, the floor is yours. Please, yes, share your screen.
I'll try. Can you see my presentation?
Almost. Just a minute, because you can see only the background of Excelsior and but not the actual letters.
Yes. And now?
Something coming up here. Okay. Okay. Please go ahead.
Okay. Okay. So thank you for having me this afternoon. Good afternoon, everybody. Sotiris said a few very interesting things for me, because he's clearly an operational guy, and I had the good fortune to visit the teleport, the Cyta teleport last year, and I was really impressed by the professional way things are handled. And he also mentioned something that is very important to me, and I will come to this in a second, which are the people. We are talking about technology, and we're talking about the space segment, the ground segment, but none of this will work if you don't have the right team. And so I would like to give you a little bit of a background on my company, European Space Imaging, and why we are interested in having a ground facility in Cyprus. So we were established in 2002. We are based in Munich. We have, this is an outdated slide. It says 40 employees. We have actually 50 by now. We are still growing. And we have about 50 people working in the Munich office and another 10 people working at the ground station, which is hosted by DLR. So we have additional 10 people from DLR working for our ground station. We are using Maxars, the US company, optical satellite fleet. About 17 years ago, we started with Iconos, the first very high resolution optical commercial satellite. Currently, we are using 4 Maxar satellites, which are WorldView 1, 2, 3, and GeoEye-1. And until early last year, we were also using WorldView 4, but that unfortunately developed a technical problem on orbit and died. But again, I will come to this in a second. These are our founders. This is Mr. Mohammed El-Kadi. He's based in Dubai. Originally comes from Lebanon, so actually not too far away from Cyprus. And Mr. Adrian Zevenbergen from Holland, and he's now based in this is the sales marketing team we have at the moment. You will find with the people I'm showing you here, it's a pretty young team, and they're already dedicated to making our whole endeavor a success. This is my team. For some reason, I ended up with a lot of women because I think they can take the stress of daily operations better, it turned out, than many men. They're really all dedicated in tasking the Maxar satellites. So many of them work at the ground station, some work in the Munich office. Said we are doing direct tasking of those satellites. Again, more on this in a second. And this is our customer support, and also a very important part of our business to have a customer support in the region, in Europe, not somewhere away in America or somewhere in Asia. So we are here in the same time zone as everybody, or more or less the same time zone. And we can react to customers' demands basically in real time. And just recently we set up a software development department because we have so much software interfaces to develop for example, for this project, that we found that it's better we pull it in-house instead of giving it to a third party. So we're doing these developments now ourselves. All right, key partners we have here, a few shown. as icons. Obviously, it's a DLR in Munich, which hosts our ground station, the GAF, and many, many others. Like we have 60 commercial entities in Europe that we cooperate with. Some project milestones, as I said, we were founded in 2002, and we started operations in 2003 out of Munich, or Oberpfaffenhofen, close to Munich. And I would like to point out the last two milestones we had, that we are participating in the Copernicus Security Service and the EMSA Maritime Surveillance Service. That contract has been renewed in 2018. So those two services that we're participating in with the MAXA satellites, those are crucial for us being interested in Cyprus as a location. I will come to this at the very end of my presentation. So these are the satellites that we used over the years. We started, as I said, with Iconos, and the latest one to be launched was WorldView 4. Iconos and QuickBird died, meanwhile, unfortunately, also WorldView 4. But next year, MAXA is going to launch 6 more very high resolution optical satellites, the so-called Legion. And they will have a ground sampling distance or resolution of down to 29 centimeters and 8-band multispectral. In the end, that full constellation of the 8 Legions at the end of next year, plus the still existing WorldView 1 and 2, they're still going strong, GeoEye and WorldView 3, I expect to operate for a couple more years. That will give us very often about 15 accesses of every area of interest within our European latitude. So if you want to monitor a site, say in Syria, you can have 15 images physically taken over a site, starting from, say, 8 o'clock in the morning until 6 o'clock in the afternoon. Because those satellites will fly in the Legion satellites will fly in a very specific orbit, which is no longer all in a polar orbit. Some of them will be in an oblique orbit. I will show you a quick animation again at the end of the presentation to give you an idea. And I will also make clear why Cyprus is so interesting for this Legion constellation. All right. So the data flow to our ground station is, this is not only a ground station that receives data, it's actually tasking the satellites. Currently we have it sitting near Munich, but we are interested in setting up a similar capability in Cyprus. So we rent satellite time once the MAXA satellites fly through our communication cone over Europe, and hopefully in the near future centered over Cyprus also. The satellite, when it enters our communication cone, it does not know what it's going to do. It has no plan. It just knows that we take it from, say, 10 o'clock to 5 minutes past 10 or 10 minutes past 10 o'clock. And then before the satellite comes, we generate an imaging plan, maneuver plan, basically. We uplink this in the first 30 seconds to the satellite, and then the satellite starts moving around and taking the pictures that we wanted to take. The data then comes down in real time to our ground station, and it's archived at our ground station, but it's also transferred to MAXA, to the central archive. Unless the customer doesn't want this, we can also have some private compartments in our archive. Right. Obviously, then we are producing products. We are processing at least level 2 and sending it to the customers from our ground station. Because we have a direct access to the satellites, it's not called a ground station per se, and it also does processing. It's called a direct access facility, or DAF for short. And again, it also comprises of an archive and also the processing facility and delivery mechanisms. So direct tasking is the key for what we do at European Space Imaging. We're not programming the satellites days or weeks or months in advance. They're highly agile. We can do basically whatever we would like them to image. We can change the imaging plan up to a few minutes, in rare cases up to seconds before we have contact with the satellite. So we can react to the weather situation. We use real-time weather. We can react to customer preferences coming in at last minute, also orders coming in at last minute. We had a case that was a landslide in northern Italy, and that happened in the morning, and we were called, and then we changed our plan for the satellite, and like an hour later, we collected that image at higher resolution, supported the relief forces with that. Also because we look into the plans in a very detailed manner. We're also maximizing the number of images or targets that we can collect. That is always better, according to my experience, than just using purely automatic software. If you have a person looking over it, it can make some more intelligent decisions than even a very sophisticated software. All right, and very crucial, and this is why I marked it here in red, is this last minute order entry and the near real-time delivery, which is super interesting for having a site in Cyprus, because it will have access to areas like Syria, for example, and then we can image parts of Syria, downlink the data, and deliver it within minutes to certain customers. This is here a few actual screenshots from our tasking system, showing you how agile these Maxa satellites are. You can see in pink the ground track over various regions over Europe. That's like Sweden, northern Germany, northern Italy, and southwestern Germany and France and Italy. So the pink is the ground track where the satellite flies more or less north to south. And the red areas are the scans that we are collecting on the ground. And the yellow line shows you where the camera is pointing. So you can see we are generating really complex maneuvers for the satellite to point at, essentially to shoot as much as we can between the clouds. These are optical satellites. Nobody's interested in cloud images. So we try to avoid cloudy areas wherever we collect. And that leads to these really weird imaging plans that we generate. So very obviously, all this data is used for commercial and also intelligence purposes. We work together with EMSAR. It's a very good and big customer of us for maritime security, like vessel identification. We do agricultural controls for the European Commission, like subsidy controls of farmers and stuff like this. And obviously, as I mentioned before, we are participating in emergency management, like landslides. A bridge collapsed spectacularly in Italy last year. There was a picture taken with Worldview 3 here. Obviously, also education and research. It's done for environmental monitoring. And then last but not least, the defense and intelligence is becoming a larger part of our business because of the known crisis regions that we have in our communication cone. Syria being one of those, of course. And energy and mining, asset management, stuff like this. And with some satellites have some frequency bands or some multispectral bands that are very suitable for geological research. All right, now that's the point here. Why are we as USI interested in the ground station in Cyprus? I mentioned before that in 2021, Legion will be launched. It's going to be 6 satellites, 2 in a polar orbit and 2 in a more oblique orbit. And that puts Cyprus in a very good strategic position for orders in the Mediterranean, preferably the Eastern Mediterranean, but also the center of the Mediterranean Sea. And when we uplink commands and downlink the data in Cyprus, this vastly improves our capabilities to serve our customers in near real time for orders that are basically in crisis regions, but also in monitoring coastal areas like illegal ships entering the European coastal areas and so forth. So this is how we developed from between 2003 and 2021. So we started out with Iconos, which is a single satellite that came into our reception cone, which is marked blue here. And we had like 3 passes per day flying from east to west through our cone. So the ground track was one. And this is the situation as we have at the end of 2020. The Maxa constellation, World 1, 2, and 3, and GR1. So you see a lot of contacts more already now in our communication cone. And finally, the next slide will show the situation at the end of next year. And I have already marked Cyprus as a potential site. There you see these oblique orbits and how they go through the center of a communication cone over Cyprus. These red satellites. So you see basically two things here. You see these oblique orbits. They need ground stations that are located further south. Plus you see so many more satellites that we as EUSI need at least a second facility to downlink, to command the satellites and downlink all the data that we're going to receive through these satellites. So this would be an example for the oblique orbits that fly over Cyprus, but also the polar orbits would benefit from a ground station in Cyprus and this red communication cone here. So yeah, this is the situation we're looking to into 2021, and this is why we are really interested in setting up a facility. And since I've visited the teleport of Cyta last year, I'm convinced that this would be the right place to set up the antenna in the production system. Thank you very much for your attention, and that's all I have to say for today.
Thank you very much, George. A very interesting presentation. Let's continue with the next presenter. We have Mr. Rani Hellerman, Vice President of International Affairs for RBC Signals. Or yes, sorry, VP of International Business of RBC Signals. Sorry for my mistake. The floor is yours, Rani. Please share your screen.
Can you see my screen?
Yes. The only thing, you should change the display settings. If you go to display settings up, or yeah, maybe the way you are trying to do it, because you have the presenter view. Swap presenter, yeah, to see it as, yes, perfect, go ahead.
Okay, thank you very much. Good afternoon, it's a pleasure, and thank you for inviting me for this talk show. And there was a dramatic change of the space segment in the last few years. We saw so many new space and old space satellites are going to the space. And we're talking about constellations of dozens and hundreds of satellites around the, orbiting around the Earth. And when we're talking about the ground infrastructure, we are, in most cases, are still in the ratio of 1:1 from antenna to satellite, or maybe 1:2. And the ground infrastructure to handle the load of this constellation doesn't exist at this needed scale right now. So the challenge is that without significant transformation in the ground segment, the value of the so many satellites orbiting will not be fully realized. So what are the solutions? First, we're talking about multi-mission ground segment as service. It means that we're talking about ground stations that serve many satellites, many types of satellites, and you can support many missions with the same antenna. So instead of antenna that built for a mission to spend 10 minutes or 20 minutes or 30 minutes a day with the tracking the satellite, now this antenna can serve many satellites and tracking, and you can use this antenna and utilize it in much more efficiency. Another important thing is the ground station is the best place to handle the edge computing. So you'll be able to make as much as possible processing at the antenna side, and then to lower the amount of data that's supposed to be moved from one place to another. So these are mainly the two main, let's say, solutions that I can see to solve the overall, let's say, the overload of many satellites around the globe. So who we are, what is RBC Signals? We are a provider of global satellite ground station as service. What does it mean? How do we do that? We aggregate the unused capacity, the excess capacity of existing ground stations around the globe. As I said, if a satellite of a ground station serves 20 minutes, 30 minutes to talk with the satellites, all the rest of the day it's idle. So we use this excess capacity for other satellites, which are our customers. In addition to use the excess capacity of existing ground stations, we also building dedicated ground stations. We call it core, which is we give all the needed capacity for the satellite operator to use the antenna as much as he needs, but it doesn't have to buy it. I mean, it just as a service. So a kind of leasing, a kind of pay as you use the antenna. Right now, we have around the globe around 70 antennas in more than 40 locations to serve our customers. Of course, not every antenna is compatible with every satellite. So for a specific customer, we check what antennas, what ground station in our network is compatible, and then we make the matching, and I'll show you how it works. So if you're talking about the space mission elements from launch to satellite TT&C and download and payload data download, we are here. We are here in the ground segment. We can also take part in the processing if needed at the edge computing, but it's dependent on the customer. But we are here in the ground segment. So if you're talking about the segments, the satellite belongs to the satellite operator, and the customer usually is the satellite operator, and we are taking care of all the layers for the ground segment: physical layers, the data link, the antenna, scheduling, networking, everything needed to take from the satellite operator the need to take to break his head with the ground segment. So this is our network right now, and we are adding more and more antennas around the globe when possible. And when talking about the antenna in Cyprus, I'm looking at it, so it looks nice to add it as well. So this is the network that we have, and the way it works. As I said, network services, we give the satellite operator the ability to find, or we find for him the compatible ground stations, and he can choose for each pass what ground station to use, and the data goes directly to him. We are not handling the data if he doesn't want to make the edge computing, but anyway, this is the data belongs to the customer. We are not making the data processing for him. So if you're talking about our portfolio, the network, as I said, this is one major service that we are doing, network services. Global network, the customer has he sees the available passes in the ground stations, and he can choose what ground station to use, and he can do it up to 48 hours, and from 48 hours up to 20 minutes, even less, before the pass. Core services, as I mentioned, for a customer who needs massive passes to access the satellite, we can give core services, usually in strategic locations. where we put a dedicated antenna for the customer, and he can use all the capacity needed for his mission. He doesn't have to buy the antenna. He just use all the capacity for a flat fee to use this antenna. In addition, we're doing, as I said, intelligent edge. We're doing engineering services. When the new mission is coming, we can help. We have all the knowledge. We have a very dedicated and very talented team and very experienced team to help the customers to make engineering and to take care of the communication. He needed to deal with the satellites. So if one wants to deal with the communication, what systems to use, what architecture to use, we can help him with engineering services. We're doing field services for some companies. We are doing all the needed work for the ground station, even if the satellite manufacturer, they want to install ground station somewhere. In some customers, with some companies, we are their right hands to deal with the field services with the ground stations. And as you know, if you want to download to access satellites from some location, we need to take care of the regulatory, and we're taking care of the regulatory services for our customers. So we are taking care with the local authorities to make sure they can download and upload the data from the ground station to the satellite. So the way it works, we developed in-house the raw system. This raw system is doing the matching between the ground segments and the satellite operator. For each pass, the satellite operator can see what stations are available for him, and he can book the ground station, the specific pass in the ground station. And when it books it and it's confirmed it is, so he can download the data in this ground station. And all the booking and scheduling and data and metadata, and also all the let's say the commercial things, and the all goes through this system. It makes it very easy. Also the accounting to do it through this system. So it's just click, and it's an API or web-based. It depends on the satellite operator needs, the customer. So we do it either by API. This is usually how we're doing, and also if needed with the web-based. So if you're talking about our competitive advantages, first of all, we are a kind of startup. We're already 5 years in the market. Our company built from very experienced people. I mean, most of us has more than 20, 30 years in the satellite business, from all aspects, operational, ground station, the space segments, everything. So we know everything needed to know about this business. We are very competitive with our prices, and we are very flexible to meet any customer need to take the hassle of dealing with the ground segment. By the way, the picture you see here in this slide is our ground station in Alaska. So we have this is a 4.5 meter antenna, a new one that can be used by our customers. So for every dealing with ground segment, as soon as possible to deal with this with the satellite operator, to define what stations he can use, and whether he can use the network or the core system, or a hybrid, which means he can have a core antenna, and in addition to that, to use some of the antennas in the network. So we are very flexible to give any solution, any frequency band, from lower frequency band X, S, X, KU, K, everything needed and we're doing with LEO satellites, MEO satellites, and also with GEO satellites, when we've made some few drifting missions to our customers when we support them with this mission. So we're dealing with any type of orbits and any type of satellites to give them the support, the ground segment support. So with that, I would like to thank you very much for the attention. You have here my email address, so if would like to continue any discussion with us about ground support, I'll be happy to do that. I still made some comments during the presentation with some people I would like to talk about for this kind of services. So thank you very much for your attention.
Thank you very much, Rani, for the interesting presentation. Let's continue according to our agenda. Next up, we have Professor Eyal Ben-Dor from Tel Aviv University, and his talk would be on the Solid Pro as a new assembly to measure soil spectral information in the field over the Mediterranean region. Eyal, please share your screen and unmute your microphone because we cannot hear you.
How is now? You can.
Yes, please, full screen.
Okay. Thank you very much, and I would like very much to.
Can you, sorry for interrupting you, can you go to the display settings and swap to the presenter's view?
Display settings in the center.
Just go to display setting and say make a swap.
Where is that?
At the top, Eyal. At the top.
Yes.
Next option, display settings.
Next one, display setting.
Next one.
Go right. Next one to this display setting.
Display setting.
אייל, אחד ימינה.
איפה? אני לא רואה.
אחד ימינה, יש לך
ימינה מאיפה שאתה נמצא עכשיו.
פה? New share?
תזיז ימינה את העכבר.
עוד?
עוד ימינה, אנחנו לא רואים את אותו עכבר כנראה.
כנראה שלא.
למעלה? למעלה?
תחת לתמונות שם יש דיספליי סטינג. לא, למעלה, עלה.
Can you stop sharing and share again?
עלה עוד פעם.
Okay, can you try to share again your screen, please?
Okay. Right. Okay. Do you see it? So I did.
Not yet.
Now it's okay?
We cannot see it yet. Maybe it takes some time to load.
Yeah, because I did see the display setting and I pressed this and should be okay now.
Still nothing.
Have you shared your screen?
Yes, I did. Do it again.
Starting now. Just to see.
Okay?
Yes.
Yeah, just press the full screen again to see your slideshow.
Okay. Is okay?
I think we can proceed with this because we are already 5 minutes ahead the timeline. So
אייל, בחלק העליון יש כפתור.
This is okay? Okay, so I'll start.
Proceed, yeah, please.
Okay, thank you very much. My presentation is actually to take us to one more environment, which I will try to show you how we can look on the ground truth measurement in a new way. And this is our study that we are actually participating with the Harmonized Cost Group Action and with the ESA CHIME mission and with the BOD Foundation. And this is how to measure and how to take measurement of soil in order to do ground truth measurement. And for that, we actually developed a new assembly called Soil Pro, and I would like to show you how it works. And the idea about the Soil Pro is that the measurement of soil in order to do ground truth measurement on, and also for other applications, for instance, agriculture applications and other applications in the field, you need to measure spectral information. And there are many ways how to measure spectral information: by contact probe, by bare fiber, and so forth. So you see many variations how you measure the soil spectral information. However, we have to remember that each of the measurement protocol make the spectral information different from one measurement to another. The most important thing about this measurement is that you are actually destroy the surface, and this is because you some of the time you touch the surface, and some of the time you don't touch the surface, and you see a lot of noises, especially water vapor spectral feature, and also other noises that come from the detector. So in the end, you cannot do analysis or quantitative analysis with soil if you are doing those measurements, because you cannot merge data together, and the end is that you cannot see what the satellite or the airborne hyperspectral sensor or even multispectral sensor see from the ground. So you need to have something that will be different from this type of measurements. And for that, we structure a new design of a way to measure spectral information, and we call it Soil Pro. It's actually under patented of the US Patent Office, and this is how it works. As you see from the left-hand side, you have the fiber optic for every spectrometer you have, fiber optic in 45 degrees looking to the soil, and then you have about 35 centimeter radii of the closed chamber, and then you have illumination, tungsten halogen illumination that imitate the sun radiation. So by this measurement, you can use any spectrometer that you have, and you can measure the soil spectral information without actually disturbing the soil surface. Of course, you don't have the atmosphere attenuation here, and by that you can have actually a laboratory quality in the field. And this is very interesting and very important for us. For instance, you see on the left-hand side measurements that were taken by bare fiber. So you see lots of variation from different time of the day. And on the right-hand side with the SP, you see measurement with the Soil Pro in those time frame. So you see that the variation of the Soil Pro is not actually changing, and also what you can see is that the water vapor is not interfering the image, the spectral information in 1.4 and 1.8 nanometer. You can see another example, and what is important is to see here the white reference that we are measuring all the time in order to calibrate the sensor. You see that if you measure the white reference in 1 hour time frame, it stays constant. However, if you measure the white reference in this time frame, you can see lots of variation, meaning that the atmosphere is changing, the nadir looking view changing, and the BRDF also is changing from time to time. So here is an equation that is developed to find out the error of this measurement, and this is how to show you the measurement error as taken from different instruments. So this is bare fiber, this is a contact probe, this is a direct beam measurement in the laboratory. So you see the error of the Soil Pro is generally very low, And you can imagine that this is taken in the field. So we have a very good instrument in the field that is even much better than sometimes laboratory measurement. And all of this done in the field. So I would like to show you why this is so important. The first important property on the surface is soil hydrophobicity. So if you measure soil hydrophobicity, you need not to actually destroy the soil surface, because soil hydrophobicity is made of organic matter, and if you are destroying the soil surface, this is that you are destroying the soil hydrophobicity. So you would like to see the soil hydrophobicity directly from spectroscopy without actually harming the soil crust. So this is to show you some experiment we did in orchard tree area in Israel. So you see that we took the spectral information, and here are the guys who are measuring soil hydrophobicity by the old way. And once you have this information and you have the spectral information for the soil pro, you can get 100 samples within 4 hours on the same orchard tree area. If you are measuring with other spectral instrument, you can get this information in 1 week or in 2 weeks together. And in the end, what you can do is mapping or having the model to map the spectral, soil hydrophobicity attenuation to the water in order to penetrate into the soil. And another information about that is how to measure the water drop, the water drop penetration time to the soil. And this is, again, this is what we get from the orchard tree. You see, we can get information, quantitative information about each spot that we measured. But then we took this assembly to Alento in Italy in order to measure the water infiltration rate to the soil. And this is again some property that is very, very sensitive to the soil crust or the soil surface. So if you are destroying the soil surface, you do not measure anymore the soil surface, and you lose all the properties that actually governing or controlling the soil into the water infiltration rate into the soil. So here again, you see a soil that is undisturbed, and this is the disturbed soil. If you take the soil to the laboratory, you are destroying the soil, and here you don't destroy the soil, and there are different soil in terms of water infiltration rate. If you measure this spectrally and you measure this spectrally, you're going to get different results. And this is what the satellite sees. And what we did actually, we are using the soil pro in order to measure this crust and to imitate the information to the satellite view. And for that, we went to the field that you see here, and we measured the soil crust by this assembly. And we measure also the soil infiltration, the water infiltration rate to the soil with the mini disc infiltrometer. And we measure it in a couple of sites in the Middle East or in the Mediterranean basin. And as you see, we have a lot of soil texture within our database, about 102 samples. And here you see from the Soil Pro, you see the models that can predict the soil the water information to the soil, water infiltration to the soil, solely from the spectral information. So this is that we want to actually adapt this model into satellite. And to do so, because we don't have satellite, and we did it with sandy soil, and we did it with clay soil, and for each of them, there were different, of course, model because of the texture of the soil. So because we don't have yet a very accurate hyperspectral sensor in orbit, we will have it in a very short time frame. We use a drone with a hyperspectral sensor on the drone in the Alento basin of southern Italy, and here are the area that we measure them with the Soil Pro. And this is actually a masking map of the vegetation, because we are looking only on the soil. And the spatial resolution was about 2 centimeters, and the spectral resolution was about 100 spectral bands in the Wiesner domain. And these are the maps that we generated. This is from the 25 samples that we measure with the Soil Pro, and this is with the gridding of more samples that we can actually look from. We can pick from the masking vegetation area. And as you see that they are very alike, and these are, of course, the right-hand side picture are much more accurate in order to provide us with the water infiltration rate of the soil and also with quantitative information. So we also went to some other places in order to validate these results, and we found fair results that could actually validate our Soil Pro in order to find out the water infiltration rate to the soil using spectral information and using this Soil Pro assembly. So in order to conclude my talk, the soil surface reflectance using the Soil Pro assembly showed very good generic model to account for soil surface area properties. And there is no dependency on the operator skill, natural condition, for instance, like atmosphere attenuation and so forth. A surface-based model such as hydrophobicity and water infiltration rate to the soil has been proved to be very accurate and could be also implemented into hyperspectral data taken from drone. I would like to mention also that the Soil Pro is a patented apparatus, but it also it's a commercial product, and there are several people, several groups in Europe already bought this assembly, and I will be very happy in the end to see how can this assembly work for ground truth measurement of hyperspectral sensor from orbit, because in the end, it doesn't actually use regular soil sample that we bring to the laboratory, but on the opposite, it measures the soil surface in the field. So in this slide, I would like to thank you everybody for your listening to me, and thank you for the organizer for organizing this very interesting workshop. Thank you.
Thank you, Eyal, very much for your presentation. Let's continue with the next presenter. We have Professor Dan Bloomberg from the Ben-Gurion University of the Negev. Dan, please share your screen.
Yeah, one moment. Change the size. You see a full screen?
The same problem as before, just on the display settings.
Okay.
Please swap. Yeah.
Yeah. So now you see.
Okay, perfect. Please go ahead. Just to hear you a bit low, if you can increase the microphone volume or come closer to the microphone.
Already. I'll speak a little. Can you hear me well now?
Yeah, perfect. Don't worry. It's fine.
Okay, so first of all, I want to thank our colleagues from Cyprus for organizing this wonderful meeting. In these strange days of Corona, we really miss some of our joint workshops and conferences, and this is a delight to have this meeting and to be able to talk to other colleagues. I also want to acknowledge my partners on this project, my friends, teammates, Dr. Shimrit Maman, from my lab, soon to be Dr. Aviran Sadon, Professor Colin Price, and Professor Stanley Rotman, and last but not least, my former student, Dr. Sivan Isaacson, that have been working with us on this whole issue of nanosatellites. And I'd like to share with you a little bit of our experience regarding the BGUSat, a nanosatellite that we launched Now it is already 3.5 years in space. And I'll start off by one comment. When we launched it, I mentioned that morning, it was about 5 in the morning on the 15th of February, 2017. I said to my colleagues, Shimrit and Abiran, if it lasts in space 1 month, we can open a bottle of champagne. And it's still in space and it's still working and still operative. I also want to thank the Israel aerospace industry, our partners, and the Israel Space Agency, whom we work with on this. So when we talk about satellite remote sensing, you know, we have already more than 60 years of Earth observations that have been used to look at Earth and actually show us that Earth is one unit and that political boundaries are totally superficial and that environmental processes occur across boundaries. Launching satellites up into space has always been a very expensive process, and a big part of the cost has always been the size. So if we look at the sizes of satellites, you can see that some of the satellites are the size of actually a bus or a pickup truck over here, going to hippopotamus, the size of the ghost satellites, through smaller satellites. And in fact, most of the satellites that are launched in the world are the sizes of about 1 or 2 tons. But in recent years, some of the universities have been working on CubeSats, which are actually a common standard that reduce the cost of building the satellite, because you're not designing the frame, you're not designing the host for your equipment, for your payload. They've all been approved, pre-approved for space flight, and you're reducing, obviously, the cost of launching the satellite. Most CubeSats are launched as piggybacks on the launch of other bigger satellites. And this is a trend that reduces the cost. It also reduces the time that these spacecrafts last in space. That's obvious, but as cost goes down, you can launch more of them. We also look at what these satellites do. So, you know, the 2 biggest uses for satellites are always Earth observation and communications. And we can see that as we go into nanosatellites, more and more are trying to do Earth observation. Very few of them are doing actually scientific research. A big part also doing technology demonstration just to try and get some technology into space and see how that can work. In the future, we believe that there'll be more and more use of nanosatellites for real applications and for scientific research. Our satellite, BGUSat, Ben Gurion University satellite, had several objectives. First and foremost, the idea was to do a technology demonstration, show that we have the capability to build a satellite together with the Israel aerospace industry and launch it, to have on it an Israeli-built bus with computer, have a camera that was built here, and in fact, do everything from womb to tomb in-house. The second part of it was actually education, to have our students experience the feeling of building a satellite, working with a receiving station, going through the whole process as you design it in very few places, normally at the national level. There were also scientific questions that we wanted to answer. Some of them were related to attitude control, and some of them were related to remote sensing. In this picture over here that I'm showing now, you can see our CubeSat. It's a 3U CubeSat, which means that the dimensions are 10 centimeters by 10 centimeters by 30 centimeters. So in fact, what you can see here in the picture is a CubeSat with solar panels on the wings over here, covered with the gold-plated blanket around it. And the whole size is roughly the size of a bottle of Diet Coke or Coke, whatever you want to drink, but it's a regular 2-liter or 1.5-liter bottle. It has a shortwave infrared imaging camera on board, and it was launched into LEO orbit, low Earth orbit, initially at about 508 kilometers some 3 years ago. Our partners, as I said, are the Israel Aerospace Industry, the Israel Space Agency, and we are at Ben Gurion University of the Negev. So the launch was successful on February 15, 2017, on board the PSLV C-37 launch vehicle from India. It was a very exciting day. First of all, it was launched on the date that it was planned to be launched. Very few launches occur like that. It was launched together with another 103 satellites. A total of 104 satellites were launched together. So in many ways, that's probably the biggest carpool in mankind, in the history of mankind. And all of these satellites were launched successfully. The biggest satellite on board this rocket was a Cartosat 2 for cartography, and another 103 nanosatellites. Actually, 2 of them were slightly bigger than a nanosatellite. They're also Indian satellites. The launch was pretty exciting. We sat and watched it happen. We designed the receiving station using mostly equipment that we purchased from Innovative Solutions in Space out of Holland. On the roof of our building, you can see over here Aviran Sadon, one of the students, I think that is online at the moment as we speak, putting up the antennas. We have an S-band antenna over here for downloading the images. We have UHF and VHF for communicating the telemetry back to our station and to the satellite. All of this is done here in Beersheba. We actually have a recording, a sound recording of the satellite. I'm not going to try over Zoom to put the sound on, but you're going to hear a beep. It sounds kind of like the old modems that we used to use when communicating one to each other on the internet, when we used the very old modems. We've collected several thousand images already. You can see over here a map of most of the images that we've collected. We've actually made them available through a website, and we can send you later the link. You'll have to register. We have to approve you to get the satellite images that come from this. But let's see a little bit more about the sensor and what the images can look like and what they might be useful for. So first of all, if we look at the number of satellites that are currently in orbit, there are roughly 5,000 satellites in orbit, of which only less than 2,000 are still active, and only about 650 are for Earth observation. Of those, there are only 220 nanosatellites, very small satellites that are used. Of the Earth observation satellites, only 11 have active shortwave infrared sensors, and only 1 nanosatellite ever has used a shortwave infrared imaging capability, and that is BGU-SAT, our satellite that we're talking about. So over here, you can see on the left a video recording from the imager in shortwave infrared of Israel. You can see the coast of the Mediterranean over here. As this goes through, I'll describe a little more. You can see the Lake of Galilee over here, the Dead Sea. In days that you could travel, I'd probably invite you to come to Israel and spend some time and probably float in the Dead Sea. You can even see, and I'll show you this over here, the political boundary between Israel and Egypt, which is demonstrated because of the change in vegetation or low vegetation over there at the border. To the right over here, you can see, again, the coast of Israel. You can see it moving over here. You can see the Lake of Galilee. And this is a May image during a storm over Israel. These two images are co-registered over here, and here you can see the clouds very clearly in shortwave infrared from our image. If we look at these two images, the two images are taken by two different satellites. And this is just to demonstrate what might be done. So as you can see to the right, the image is in a similar wavelength taken by one of the NOAA satellites over here. I think that it's a NOAA 17 image, I'm not sure, 17 or 18. To the left is the image from our little CubeSat, which is only 10 by 10 by 30 centimeters. And you can see that the quality looks better. I hope that you can see it also on your screens over there. So we've done several comparisons with other satellites. We feel that using BGUSat, the disadvantage is, first of all, that you only have one band compared to the NOAA 17 satellite over here with 5 bands. But at a much lower cost, you could launch 5 satellites and get all 5 bands. Their ground resolution on our satellite is about 600 meters, whereas on the NOAA satellite, it's about 1 kilometer per pixel, actually extends to 1.1 kilometer. So we feel that we have something over here that provides us with a pretty good imaging system at a much, much lower cost than many of the other big satellites. We developed the browsers that you can download images, and this is what the screen looks like. As I said, we'll be able to send you the link. You'll have to sign up for it. We have to approve it. You'll be able to download images straight from the website. And you can see, obviously, a lot of the images are over Israel because that interests us. At this point, we cannot direct new collections, but we have a lot of images on the library. And in the future, it's a funding issue. We'll download more and more images. We also defined several scientific questions that we want to look at. For example, together with Professor Colin Price from Tel Aviv University, we're looking at Earth glow using shortwave infrared. We're looking at floods in desert areas and trying to see what we can derive from 600 meters spatial resolution. We're also doing change detection for environmental research before and after rainy seasons. And we're also looking at cloud coverage using the shortwave infrared image. From that, we want to go in the future to build another satellite. And for that purpose, we've been working on new methods to develop smaller hyperspectral images. And we have a design and a patent over a hyperspectral compressive sensing imager that we designed here at the university. We want to call the next satellite NegevSat, but obviously that's a temporary name until we fully develop this. We've been doing experiments on using this compressive sensing imager and thinking about the future of it. So with that, I would like to end my presentation. Once again, I want to thank the Israel aerospace industry and the Israel Space Agency, our partners of BGUSat, and the patch that you can see over here is the patch of our satellite. You can see Earth, you can see the satellite itself, and you can see the image of Ben Gurion here in the background. So thank you very much, and with that, I'll end.
Thank you very much, Dan, for your presentation. Let's continue with today's agenda. Next up, we have Professor Yannis Gitas from the Aristotle University of Thessaloniki. Yannis, please start sharing your screen.
Thank you very much, Mario. Thank you very much for the invitation. Thank you very much for organizing such an interesting event. Give me a minute. You see my screen now?
Yeah, just start the slide so we can see it full screen.
I'll do that. Yeah. Is it okay now? Is it better?
Yes, please go ahead.
Okay. The title of my presentation is about the National Observatory of Forest Fires we have established here in the University of Thessaloniki, who apparently is one of the main supporters, as you probably know, already, of the Excelsior project, gaming project. We are going to show you how we see how the developed services we've done through the observatory can be used as an example for collaboration in the Eastern Mediterranean region. As I said before, this is a national project that is supervised by the Greek Ministry of Environment and Energy. This is a collaboration between the University of Thessaloniki and the Inter-Balkan Environment Center. Our friend and colleague, Professor Zalidis, is going to be the next presenter. So he is the main investigator from the IBEX side. The project, which started 5 years ago, aims to develop products and services that are related both to the prevention of the fires and also to the impact assessment of forest fires. So in fact, the general concept here is that we'd like to produce products and services that are related to both the pre-fire management and the post-fire assessment. And the second aim we have with the project is to promote collaboration with other countries, mainly the Balkan region, but also, as you will see later in the next slides, in other parts of the Eastern Mediterranean. We have actually, these are the services we have developed already, but now we are in the phase of developing new services, 2 new services that are related to post-fire assessment that are not mentioned in the slide. Anyway, today we're going to focus on the services that have been developed so far under the National Observatory of Forest Fires. Starting with the fuel type marking service. The fuel type marking service is an up-to-date mapping methodology. The idea here is not only to use to rely on existing satellite image data, but also to somehow use and take advantage of existing national and European mapping products. And also, what we'll try to do when developing this service was to use minimum possible available data and to provide a maximum highest accuracy possible. Since we come from a forestry background, we're very used to focus on the accuracy assessment of our products. So this is the first product we produced in 2016-17, and we then, we had the opportunity to have field surveys and also to use European-wide available Lucas data in order to check the accuracy of our product. As you can see here, the accuracy is very high. And the idea was also to have, services and products that are easily updated. So the idea was to have a product that could be updated easily on a yearly basis, on an annual basis. I would like to mention also that this is the second product we developed. The first product was under the Life Arc Fuel project. It was developed before, during the period 2012-2015. And the first version of the product was awarded as Best Life Nature Project of the year 2014. So the second service I want to focus is the so-called Nofio BAM, or our burnt area mapping service. This is an open QGIS plugin software we have developed using our own object-based image analysis system. So we're not using any commercial system. We produce our own algorithms, and we use state-of-the-art machine learning algorithms and freely distributed satellite data, such as Landsat, Copernicus, Sentinel-2, etc. And we try to minimize the interaction with the user and produce more or less semi-automatically the bent areas after the request coming from the Forest Service of the country, Greece. So far, we have been we had the testing period during the first 2 years, 2015 and 16, and then operationally from 16 to 20. So this service is still running. And so far, we have mapped more or less 70,000 acres of bent areas. You can see here the distribution of the bars, the different countries in which we used our service. As you can see, Cyprus is one of the countries that have been applying our service in collaboration with CUT. And so far, we have, this is the distribution of fires we have been mapping every year since 2016, as I mentioned before. Talking about now the service itself, we provide the results to the National Forest Service, to local Forest Service departments, where the requests come usually either from the Forest Service or the local forest departments of the country. And also we provide copies of our final products to the General Secretariat for Civil Protection and the other stakeholders such as WWF, NGOs, and research institutes, not only in the country, but also from the neighboring countries as well. These are some examples of the type of mapping we are doing. I would like to mention here that the methodology was co-developed together with the Joint Research Center of the European Commission, the Forest team. And these are some examples coming from Cyprus. As I said before, we've been developing this, applying this not only in Greece, but also in other countries as well. And here you can see examples from older fires in the areas of Soleas and Argaka. Another example that comes from the Greek-Albanian border. In general, this was quite well accepted as a service. Actually, we were rewarded as one of the five best applications for the benefit of the citizen from the Copernicus NERES program. So we had to be 1.5 years ago, in December of 2018, there was a special ceremony for being awarded, and that took place in the European Parliament for the quality of the service. And as I said, the focus here was the benefit of the citizen. And as I said before, this was mentioned already, that the collaboration of the methodology was the collaboration with the General Research Center. And one major thing we tried to do here was to work together with the Inter-Balkan Environment Center in order to disseminate not only the knowledge transfer, disseminate the results to the neighboring Balkan countries. Another product that we've been developing in the last 2 years is the so-called Midterm Forest Fire Danger Index, which differentiates from the daily fire index produced on a country level by the Civil Protection Agency, not only in Greece, but also in other countries as well. So what are we doing in this service? We try to do the midterm 8-day in advance prediction of how the situation in the specific year compares with the situation of the dryness of vegetation in comparison to the years before. And as an example of that, of course, this is also again in this case we're using free and open source programming environment. In this case, this is R. And the idea here is to do as I said before, predictions well in advance by taking into account statistical data, and to find out whether there's a high or low opportunity for in an area to start a fire. And these are examples that were computed for all fires, because in this case, as you can imagine, you cannot really use this for mapping new fires, but this is really to use historical data to see whether your model predicted well and accurately older fires. Another thing we have been developing, and actually have been funded this year as well, is to develop a new platform for a viewing service for serving this to the community, all these services I mentioned before. This is our old website, and this is the new service we're developing now. And it's a part of the National ESPA project, which is funded by ESPA. And this is open to the public, but also we have a version that is only open to the Forest Service, the local forest departments, and also the central service that is based in Athens. Another important thing we've been doing is that we developed a network of partners that are based at the local forest departments, So we have a national network of people that are not only collaborate with us at local level, but also we collaborate with people in order to develop accuracy estimates of the products we produce. And by that, I would like to thank you for your attention and also thank you for the invitation to be here. You gave me the opportunity to present our work in this forum today. And congratulations for the excellent organization of the event.
Thank you very much, Ioannis. And we will conclude this session with the next presenter, Professor George Zalidis. He will, from the University of Thessaloniki and IPEC, and he will talk about the Earth observation data and services for carbon-reduced agriculture. George, hello, please share your screen.
That's what I'm trying to do. Give me a second. I would like also to congratulate, and since this is the first Excelsior technical meeting, I really would like to wish you a very successful roadway. We are going to be next to you all the time in order to really hold on a second, it seems like we have a problem here. Γιατί δεν το έχουμε εδώ? To open the presentation. And going from the forest to agriculture, I would like to speak for the new carbon-reduced agriculture, since in the new common agricultural policy, this is the issue that the European agricultural community has to face in order to really comply with the new regulations, but also with the new challenges in using Earth observation, data and services for, why we don't go to the next slide. Give me a second. Okay, I think we did it. Here is the main idea behind really being able to incorporate in the river basin approach all the components of the carbon introduced to the atmosphere, taken from the atmosphere through the biomass produced and by storing the carbon biomass into the soil. So implementing practices, agricultural practices, we need to really improve the rate of which CO2 is removed from the atmosphere and converted either into the biomaterial through the plant or to the organic matter. All this issue of the carbon-reduced agriculture has to go through the so-called nexus approach, which is the environmentally friendly agriculture, which takes into account water, energy, and food security, to three main pillars of sustainable development goals. Examines the interdependencies and the interdependencies, examines resources transition across spatial scales from the river basin to the field, strengthen capacity for adaptation to climate change and mitigation measures to climate change, and it relates resources necessary for agricultural production to their integrated management and resilience to, this is a very important issue now, public health, since we're living in that COVID area. The next approach is a sustainable development goals from food, water quality to health, and I'm going to really talk very briefly through this triangle of agriculture, energy, soil and water resources, where in terms of geo, we have the new land degradation neutrality initiative, where really there are three components to that: land productivity, carbon sequestration, and land use, land change component. So in order to really secure food security in our Mediterranean area, we have to make sure that this three-way interaction between water, agriculture, and energy, with all these interdependencies, and how this relates to the food security issue and to the health security issue, is very important indeed. Another component with the carbon-reduced agriculture, of course, enters into the Sustainable Development Target goals. All of you are familiar with the proportion of the area under sustainable agriculture, which is Sustainable Development Goal 2.41, and collection and integration of different spatial and temporal resolution data, that's spaceborne, and of course, production of quantitative estimates of mapping products on ground concerning agriculture, depicting carbon-reduced agriculture. The whole process of monitoring this agricultural sustainable practices is going through this process. Of course, we have all the Earth observation to the left, the Earth observation data coming from spaceborne, including, of course, the crowdsourcing department, and of course, all the IoT component where we have the telemetry, and we have the connectivity and the adapters and different apps where they translate this data in not only to sustainable development goals, but also to societal benefit goals and concerning, of course, food security. Earth observation, geospatial information and modeling, along with statistics and estimated data from administrative natural boundaries is very important. The whole concept can be seen in a very diagrammatic way, how the soil organic carbon, through its carbon stocks, can be translated into knowledge, through knowledge, to the sustainable development goals and societal benefit areas, as I said before. With Yannis Gitas, we really work together very hard to make the first ICOS network. Sorry, but I have to go back to the diagram here, where we have the first station which monitors really atmospheric gases from the ground to the canopies, to the atmosphere, and all these exchanges through a very innovative system where the first time will be implemented in the Pertuli area. And the whole scheme here shows how carbon monitoring scheme through the life for carbon and all these parameters that are getting into the system. Of course, we need to create the network for monitoring and, of course, to have all this into the business model that these services will be delivered to the farmers. The ongoing innovative solutions, and we heard before our colleague and partner from Tel Aviv University, Eyal Ben-Dor, talking about the soil probe, where here you see a version of it, which we did it for soil scanning, which is pretty much the same concept, which is the mobile soil sensor. We co-developed it along with the Tel Aviv University. We include the new technology of MEMS and spectral libraries into the field diagnostic toolbox, where the ongoing crowdsourcing is a very important component into the Earth observation concept, and finally working together with selected geo-initiatives, which I'm going to briefly outline to you, where really, as an Excelsior, we need to build upon already gain experience in the different regions of Mediterranean that we have been working together all these years, and really be able, through the Excelsior project, to capitalize upon them. Expected impact is to improve spaceborne and in situ component of essential variables monitoring with direct links to existing geo-initiatives. I presume that Haris Kodes has spoken about it this morning. Improve in situ Earth observation data and services related to specific Copernicus products. That's also very important to incorporate into what we're going to envision working through the Excelsior, and create a validation and calibration, of course, for air and spaceborne sensors. And the example that the soil probe was mentioned to you before was a very good example. Through the remote sensing, I'm mentioning here some efforts that they were really run in the past, and see how data from different satellites have been really compared to test for soil organic carbon in the soil, and different efforts that have been going on from 2008 to 2018 from different scientific groups, which really shows that what effort really we are doing in the field can be really very important in the next generation of hyperspectral data that we're going to be having through the remote sensing data. We are employing here in IBEC and Aristotle University, who are very strong partners to Excelsior, a multidimensional data cube effective solution on the flight. That's through the CSIRO center, where really, along with NASA, they provide this open data cube approach for all satellite support infinite number of applications, and open source software approach really expands our remote sensing capabilities in terms of processing data. And again, you see here how important it is to have these so-called soil spectra libraries, and Eyal has mentioned before, and see how really we can combine data on the spaceborne version with crowdsourcing obtained into the field, and of course the libraries obtained in the lab, to have a very good regression analysis concerning soil organic matter, which is a very important component in terms of really verifying that both agriculture as an output in terms of carbon accumulated in the biomass or in below ground soil component really constitutes an important element in the new coming reduced carbon agriculture. As Eyal has mentioned, it's very important to have precise standards and protocols to ensure the integrity of the results and be able to produce very accurate biological, chemical, physicochemical, and physical soil properties that already have come out through the GeoGrad project that we have run the years before. We have worked together here to build, and of course Eyal was an important parameter into that, to build the Greek soil spectral library consisting of close to 500 soil samples, chemical analysis of soil organic matter, and of course a standard protocol that has been developed by Eyal back in 2016. And you see how good is the regression between the predicted soil organic carbon and the real soil organic carbon. And that's only one component. Of course, physical properties that Eyal has mentioned before are very important in working together and trying to fuse all Earth observation components from spaceborne to ground sourcing and all the intermediate
George, sorry for the interruption. Try and conclude with your presentation, please.
Yeah. I'm concluding in a couple of seconds. Of course, as I said, it's very important to incorporate all the geographical data and the data that have been produced in the case of GeoSSS. And we are at the point where Earth observation data for low carbon footprint sustainable agriculture, in order to improve all the soil quality, of course, based on land degradation quality, and offering reliable Earth observation data. It's important to create the ecosystem that are shown here, and that's why Excelsior is a very important element into that. And of course, I don't want to go very deep in many more aspects of it, but incorporating initiatives like GeoGLAM and GeoGradle and InShape that have already produced the tools for the agricultural tools that they have to be incorporated into the Excelsior business plan is very important. Having said that, I would like to really thank you for the time, and we have developed already tools that they have a very high technological readiness level to be incorporated into the Excelsior project. Thank you very much.
Thank you, George. We have set some questions in the Q&A for all panelists. I will start with the first question from Mr. Nikos Sikas. How can we cope with negative black swans, unknown unknowns? I think this was mentioned for Mr. George Ellis, but other speakers can also answer to that question. It's a general question.
Okay. If you think it's addressed to me, what do you mean by...
That's what I understood from the participant, from the attendee.
Okay. What exactly do you mean by unknown unknowns, the black swan? What kind of things would you imagine?
Okay, let's wait then for his next question. Maybe he will go back with some more clarification. So let's continue with the next question from Mr. Lipidoforos Anastasiou. I think this was addressed to Professor Dan Bloomberg. He's asking if you use plasma thrusters to stay in orbit for so long, for this long. Dan, you are muted, so if you can... Dan, we cannot hear you. No response from Dan. Actually, 3 out of 5 of the questions are addressed to Professor Bloomberg. Mr. Sikas, black swan, a very rare but a predictable event with huge consequences. Mm-hmm. So George, that's the clarification.
Okay, I'll try to do my best, and I'm not sure if I'm the right person to ask this, but what can we do? I mean, if you have these kind of uncertainties in the Earth observation business, the only thing you can counter is that you basically observe and monitor as much as you can. If this is the question, I mean, the observations are all in part located in areas where you know there are some things going on, but of course we also do mapping and observe areas where we think, or maybe we have no clue what's going on, and this is exactly to find out what you don't know. I'm still not sure if this is the answer you want to hear from a point of observing areas on the ground with very high resolution. Like monitor as much as you can, and map as much as you can, map as often as you can, to make sure that you find the stuff that you're looking for and find surprises that you're not prepared to. if that answers the question. I'm not sure.
Nikos, I hope that answered the question. If you didn't get what you expected, please come back to the Q&A. Anybody else from the panelists that would like to answer to that? Professor Bloomberg, can you listen to us? Can you hear us? Okay, let's continue to another question from Mr. Mustafa Majid. He's asking, how can we stop land conservation, maybe conservation? Maybe it's a typo. Maybe. I think this is addressed to Dr. Ioannis Gilas or Dr. Zalidis.
The question again? Can you repeat
the question was, how can we stop land? I think it's called, it's conservation, not conversation.
Okay, because I really missed the question. So it's probably the question addressing the land degradation neutrality, where I mentioned the three components, which is land productivity, land use, land change, and carbon sequestration, that means carbon storage in the soil. So these are the three parameters in the land degradation neutrality, where we really need, through the indicators that we have developed, in terms of land productivity, there is specific indicators to show how productive the land is. In terms of soil organic carbon, we have a specific 15.3 indicator showing and indicating how good soil acts as a sink to soil or to atmospheric carbon. And finally, we don't want to really change the use of land for productivity when we have unsuitable land change. So these three, when combined, really we talk about the new concept of land degradation neutrality, where it's a must issue for SDGs. And of course, there we combine different sustainable development goals through the monitoring using Earth observation. And each member state, and of course here we're talking about the Mediterranean states, they have to report on how well they have performed in terms of sustaining land productivity and land neutrality overall.
Okay, thank you very much. Unfortunately, the other three questions are for Professor Bloomberg, but he doesn't seem to, maybe he's not with us any longer. Yeah, the question is about land conversion. So I think, George, you understood well here.
I think I guess it right, because it's the land use, land change initiative. Yes.
You're right, yes. So for the rest of the questions, because we cannot get Professor Bloomberg back with us, we'll try and send these questions to him, so he will respond to you by email. Okay, so we will continue with the next session. And we have 1 minute. We have
a break now.
A short break now, yes, Eleni, you're right. Up to 3:15, right?
Yes, exactly. We will be back at 3:15 Cyprus time. So see you in a bit.
Thank you all.
Thank you.
Thank you as well.